So, igneous rocks. You need to have your earth science reference table out and in front of you, opened up to page 6. Because on page 6, we are going to start the igneous rock identification chart. Okay, so make sure you have this out while I'm going over the notes as you're writing them into your note packets as well. So, a rock, rocks, okay? They're naturally formed solid materials that make up the Earth's crust. They're based on the origin and formation. So how they are identified is where they formed and how they formed, okay? There's 3 main categories of rocks. You have igneous, sedimentary, and metamorphic. You've learned these before. These are things that you've covered in middle school. But now we're gonna go into them a little more in depth, okay? So, what minerals do you see? Well, in this rock, you'll see mica, you see feldspar, and there's quartz all mixed into this rock right here. In fact, this would probably be a nice countertop because it's granite, okay? Now, monomineralic means it has one mineral in it. So rocks are only formed from one mineral, like rock salt. Rock salt is made from the mineral halite. Limestone. Limestone is made from the mineral calcite, okay? Polymineralic means it's made up of many minerals, lots and lots of minerals mixed together. So rocks that are formed from more than one mineral. So this piece of gabbro, it's an igneous rock. If you look on page 6 of your reference tables, which you have out already, you can see that gabbro is made of plagioclase, feldspar, pyroxene, amphibole, biotite, and olivine. It has different percentages of it in there, and it can cause it to be a little bit of a different color. Like if there's more olivine in it, it's gonna be a greener color. If there's less olivine and more biotite and amphibole, it's gonna be a darker, blacker color. But it all depends on the amount of minerals in it, okay? So igneous rocks are actually classified by how they look, their crystal size and crystal structure. Not structure, just crystal size, sorry. So this is the igneous rock chart. I may do another video just to break it down and show it to you a little bit better and use some colored drawings, but you can see the rocks are named in this section right here, okay? There's identifying pieces over here, there's identifying pieces over here, and then you actually can follow the chart straight down to see what rocks or what minerals are actually included in the rocks, okay? So you have your extrusive, which says it's volcanic. These are formed on the exterior of the earth, meaning it was a volcano erupted or the lava was out on the surface of the earth and it cooled, or it cooled in the ocean. And then you have intrusive. Intrusive means it cooled inside of the earth, all right? Then there's this piece right here that we're going to talk about. It talks about color, density, and composition. You'll be able to know which side is which and what they look like. So igneous rocks cool from this and solidify from a molten rock. In order to be an igneous rock, it had to be melted before it cooled into something. If you follow our rock cycle chart, you can see that you have to start with magma and it has to solidify in order for it to be an igneous rock. All of them have to go through melting. Like if an igneous rock wanted to become an igneous rock again, it would have to melt. For a sedimentary rock, in order to become an igneous rock, it would have to go through a melting process and become magma and then re-solidify. Same thing with metamorphic, okay? You actually can find this on page 6 of your reference tables too, up in the top corner. So, different types of molten rock. You have magma and you have lava. Magma is the hot molten rock that comes from the inside of the earth. Can you see magma? No, because you're not inside the earth and you can't go inside the earth to see it because you'll melt and you'll be like a fireball, okay? Then you have lava. Lava is the molten rock that is on the surface of the earth. Magma, lava, okay? These people are pretty close. You have to be really careful if you go to a place like this because if the rock is just starting to solidify and you step on the wrong spot and you break the rock, you actually can fall through into the lava. Also, the rock gets very hot around there. It can actually melt the soles of your shoes and expose your feet to it. And you'd have cooked feet. Yuck. So here's some more pictures of lava. So sometimes actually the water around this area would actually be boiling because of how hot it would be getting. And the rock is actually going to cool much faster when it hits the water because it cools it faster. We have more lava there. So what is crystallization? So it's when the cooling and solidification of molten rock happens and these crystals start to form. So you have your molten rock and it's in a liquid state. Once it starts to solidify and it starts the cooling process, these little crystals are going to start to grow inside of it. And as it cools, the crystals get bigger and they start to interlock with each other until it creates a network of intergrown crystals. Okay, and then all the magma is used up and everything inside of there is cool and you can finally touch it. So there's different types of igneous rocks. Again, I'm on page 6 of my reference tables. You have your intrusive rocks. Intrusive rocks cooled inside of the earth and they cool slowly. Because if you think about it, if you have something that you're baking, so say that you have a cake and you put your cake in the oven to cook it, okay? And the timer went off, it's time for the cake to be done. Do you turn off the oven and leave it inside of the oven to cool off? Or do you take it out and you set it on top of the stove? You would want to take it out and set it on top of the stove. That's right. Why? Because even though you turned off the heat inside the oven, it's still going to hold the heat in there. Why? Because those ovens they're insulated so that the heat does not release or escape from it at all, so that the heat stays inside of it to cook things. Okay? When rocks or when magma cools inside of the earth, it's almost like an oven that once it starts to cool, it's not releasing the heat out very fast. So it's going to take a really long time for things to cool down. In fact, sometimes it takes thousands and thousands and hundreds of thousands of years for some of that magma to cool. When it takes that long, the crystals get bigger. So when you go to a place like there's the garnet mines up in North Creek, and you see these like beach ball size garnet crystals in the rock, that's because that rock, when it was cooling inside the earth, allowed enough time for that crystal to grow. It took thousands and thousands of years for it to cool and those crystals could grow. Okay, so intrusive means it cooled inside the earth, big crystals. This is also an igneous intrusion. It's when the magma can push through different cracks of the rock and then it will solidify inside of there. This is a basalt inside of what may be a limestone. I'm not really sure. I have to see it up close. Extrusive means it cooled on the exterior of the earth. It formed from lava outside of Earth's surface. It cools very quickly and it's a little to no crystal structure because it didn't have time for those crystals to form. What happened was when it solidified, all of those little itty bitty crystals that were starting to form inside of it couldn't get together. So it just cooled all in one big block, basically. Okay, so extrusive cools on the exterior of the earth, teeny tiny crystals. This is the Kilauea Volcano. This one has slowly been oozing for a very long time. A couple of years ago, it was very active. In fact, it did erupt enough that it went into some neighborhoods on different parts of the island. There were some cool pictures that the lava went into a graveyard and the headstones were just sticking out of the lava that was going through there. It was kind of cool. This lava, as you can kind of see, it's kind of smooth when it is cooling. This is called pillow lava because when it does cool, it's kind of smooth. There is another type of lava that in Hawaii that when it cools very quickly, it's kind of sharp. They call that ah ah, because when you walk on it, you go ah ah ah. Okay? The Hawaiian volcanoes are all over. So this guy actually, you can see, Hawaii is it's not cold. It's probably not cold there, but he has all of that protective fire gear on. So because it gets very hot, the closer you get to that lava, it is hot to the point where you, like, your clothes could probably catch on fire if you got too close to it. So what is A? A is lava. B is magma. Specifically, B is an igneous intrusion of magma. And then K, what K looks like is it was one of these. It was an igneous intrusion, and everything around it eroded away. But because K was made up of a different rock, it didn't break as easily as all this other rock around here. So K is actually an igneous intrusion from a long time ago. Good. Now, how are igneous rocks identified? With this lovely, confusing looking chart. All right. So you have the texture, which is the crystal size, are the same thing. Texture and crystal size go hand in hand with each other. That's why they're on the same part of the chart. That's why they're housed next to each other. They're friends. Okay. So then you have color, which is going to be either dark or it's going to be light. Then you have density, which is either going to be a higher density or a lower density. And then you have mineral composition. Is it going to be mafic? Mafic means that it's rich in iron and magnesium. Or is it going to be felsic, which is high in silicon and aluminum? Okay, so I'm going to show you how to use this chart later on. Difference between them, you know all of them. So texture of igneous rocks. These are all different types of igneous rocks. Actually, the texture gets bigger as you go through them. It's kind of small here. These crystals are a little bit smaller, and the crystals start to get bigger in these ones. It's really hard to see in these pictures. I'm sorry. So the relationship between cooling and texture, that the longer it takes to cool, the bigger the crystals are going to be. Okay? The longer it takes to cool, bigger the crystals, the coarser the texture is going to be. So if something is intrusive, it's going to be formed and cooled inside the earth. It takes a long time to cool. It has big crystals, and it becomes coarse or very coarse. Now, when I mean big crystals can be like the size of dimes, or they can be the size of beach balls. Okay, there are some igneous rocks that can make crystals that are the size of a human, which is really rare to find, but they're kind of cool if you find them. Okay, then you have extrusive rocks, which are volcanic. They cooled on the exterior or the outside of the earth. They are faster cooling, and because they cooled so fast, they can be a fine or glassy texture, or they also can have gas pockets. Because sometimes the bubbles inside of them, it's bubbling so much that when it cools, the bubbles kind of get stuck and they pop. They actually make like these little gas pockets in it. And they're pretty cool to see. They're very teeny tiny. It makes the rock pretty light as well. So what's the relationship between color and density? So if it's light, low, and felsic, it's going to be on the left side of this chart. Okay, so if anything is going to be dark in color, high in density, and mafic in composition, it's going to be on the right side of the chart. This stuff over here is light. This stuff over here is dark. This stuff over here is less dense. This stuff over here is more dense. This over here is going to be felsic. This over here is going to be mafic. Light, dark. Less dense, more dense. Felsic, mafic. Got it? Okay. So where can igneous rocks be found? Near a volcano or deep below Earth's surface. If you didn't know this is pretty cool. Up in Schuylerville, off of Route 4, so if you're going north towards, if you're going north into Schuylerville and you're gonna go over one of the bridges, there is this place called Stark's Knob. And Stark's Knob is formed from a volcanic rock that was called pillow basalt. And it's not an old volcano. So what happened is, deep down under the earth, there were these blobs of basaltic magma that started to rise up, and then they started to cool as like these blobs. And so it made this like pillowy rock under the surface of the earth. But then a lot of the rock on top of it started to erode away, and it exposed these pillows with this pillow basalt. Really cool to go see. Off the side of the road. It is kind of mucky and muddy there in the springtime, so you might have to wear boots or just make sure you wear old sneakers. But it's pretty cool to see. Because what happened was, deep down under the earth, you had these pillow basalt pieces come up. This is a really hard picture to see. But this is what it looks like. But when you get close to the top, or there's different areas down at the bottom, you can see the pillow-like structures underneath, which is pretty cool. So, igneous rocks. You're going to do questions all on your own on a different thing. Igneous rock chart is page 6 of your reference table. I will do another video that I'm going to do different color coding and show you how this works. Okay, it'll be much shorter than this one because you're going to need to go over this and know how this chart works. Good job. Igneous rocks.